Okay, let's go through example 12. This time we've got to find the identity for sine to the power of 4 theta. So we are going to look for this expression and finding the values of D, E and F. Okay, so clearly here we've got to use the identity involving sine. So we're going to use z minus z to the power minus 1 is equal to 2i sine theta. Let's just find what sine theta must be. So it's equal to 1 over 2i z minus z to the power minus 1. So we're going to raise this one to the power 4. And we're going to get sine to the power 4 is equal to, let's just really be careful. So we'll raise this one to the power of 4 first. Let's write it down. And then we'll do binomial expansion on z minus z to the power of minus 1. Okay, so here 1 over 2i to the power of 4 is simply 1 over 2i to the power of 4. So this is 1 over 16i to the power of 4. And I to the power of 4 is made out of I squared times I squared. So it's minus 1 times minus 1. So it's 1. So we're looking for 1 over 16. So it's 1 over 16. Let's use binomial expansion. Z to the power of 4. Oh yeah, by the way, the coefficients for this one are 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. So we are looking for the next term to be 4 z cubed and then 1 of z minus z to the power minus 1. Then we're going to have 6 z squared and minus z to the power minus 1 squared. And we're going to have 4 z minus z to the power minus 1 cubed. Run out of space here, let's just put it down here. Plus minus z to the power minus 1 to the power of 4. Okay, next step, we're going to tidy up each term in our expansion. So it's z to the power of 4. Here you've got positive times negative, so it's going to be negative 4. 3 minus 1, you get the power of z squared. Over here you've got minus raised to the minus 1 raised to the power of 2, so that will stay as 1, so it's positive. Squared and minus 2, add them two together and you are going to have z to the power of 0. Let me just write it down. You will have z squared times z to the power of minus 2. So that must be z to the power of 0, which is 1. So that will give us 6. This one here, you've got an odd power, so this one will have to be minus 1 times 4 is minus 4. And then the power is going to be 1, take away 3, so it's minus 2. And finally, this one raised to an even power of 4. This is going to give me positive z to the power of minus 4. Okay, so now we are going to find pairs like we did in the previous example, and you always do that. If you can't find pairs, you will see that in this situation it will only happen for this, which is a constant. We wanted to have a constant. But if you can't find a pair with this one, then you've made a mistake. But here, hopefully that will work. There you go. So here's my first pair, z to the power of 4. Add z to the power of minus 4. Next one is minus 4. And then in brackets z squared, add z to the power of minus 2. And then obviously we've got plus 6. Okay, so strangely over here, although we started with sine expansion, which is with a minus, we ended up with the causes, and that's what we expected because each of those represents a cos. Remember, so here we're going to use the identity z to the power of n plus z to the power of minus n equals to 2 cos n theta, we are going to obtain 1 over 16. The first one is cos 4 theta minus 4, very carefully, don't forget to put the 2 times cos 2 theta, and then plus 6. So just expand this, you will get 1 over 16 cos 4 theta minus 1 over 2 cos 2 theta, and finally 6 over 16 gives me 3 over 8. So the value of D is 1 over 16, the value of E is minus 1 over 2, and the value of F is 3 over 8. There you go. Job done. So now you can go ahead and have a go at the remaining questions of exercise 1D and the relevant questions from the review exercise that follows. There is not enough practice questions and it would be a good idea to actually go back and redo the previous ones as well. Okay, so let's go through part B on example 12B. We are going to use the results that we obtained in part A to replace sine to the power 4 theta, then integrate the answer. So you cannot integrate sine to the power 4 when it's in this state without replacing it with for another function that you know how to integrate. So sine to the power 4 theta, we found that this is 1 over 16 cos 4 theta minus a half cos 2 theta add 3/8 d theta. So if you haven't done integration yet, cos, so if this is your f of x, cos theta, the integral of this function is going to be minus, so of cos theta is sine theta, sorry, not minus, sine theta, and then sine theta integrates to minus cos theta. Now if you've got a k in front of a theta, for example cos k theta, that goes to 1 over k sine k theta, and if it was sine k theta, that would go to minus 1 over k cos k theta. Okay, so over here we've got to use this result to do the integration. So let's actually do the integrating. So get rid of the integral symbol, and we're going to divide here by 4. It will go to sine 4 theta, so it's 1/16 times 1/4 sine 4 theta minus, this one is going to be a half times a half sine 2 theta, and then 3/8 is just a constant that goes to 3/8 theta. Let's put the limits at the end here. Okay, so this is going to be, let's evaluate this. It's always important to substitute the limits in. So 16 times 4 is 64, so it's 1/64 sine, let's put the first limit, so pi over 2, minus, here it's going to be 1/4 sine 2 times pi over 2, and then 3/8 times pi over 2, and we're going to subtract. Let's put the 0 in, so 1 over 64 sine 0 minus 1/4 sine 0, because it's going to be 2 times 0, plus 3 over 8 times 0. Now if you know that this is going to be equal to 0, you should still write at least minus 0 as your lower limit, but I've put it fully. Okay, okay, so over here you're going to have 1 over 64, you can pop it into the calculator now, sine 2 pi, so that will give you 0. This one here is going to be 1/4 sine pi, so that's again 0. And this one is going to be 3/8 times, so it's 3/16 pi, and then minus 0. So the answer is 3 pi over 16. Boom. Okay, so now you're ready to go to exercise 1D and complete all the questions, and also review exercise and complete the questions that go with Demois's theorem. Very, very important to make sure that you've done as much practice as possible. You may leave actually review exercise till you finish the chapter.